Let's take a look at A-Level 2024 H2 Math Paper 1. For our first question here, we are given the equation y equal to x plus 1 over ax squared plus bx plus c. And it has also a vertical asymptote at x equal to minus half. And the graph also have a turning point at minus 2, minus 119. And our objective is to find the values of the unknown a, b, and c. We have here y equal to x plus 1 over ax squared plus bx plus c. And we know for vertical asymptote is the value of x that cause y to be undefined. And we know that if the denominator here is equal to 0, you will be causing y to be undefined. I will know that since x equal to minus half is the vertical asymptote, I'll know that if I will be subbing x equal to minus half into the denominator, I will be getting equal to 0. And here, let's do a bit of simplification. We have 1/4 a minus half b plus c equal to 0. I will call this equation 1. And since the question also tells us that the turning point is equal to minus 2 minus 1 over 9, I will know that this particular point will satisfy this equation by subbing these coordinates into the expression here. I will end up with this a minus 2 squared plus b minus 2 plus c. And let's do a bit of simplification here. I'll get minus 1 over 9 equal to minus 1 over 4a minus 2b plus c. 4a minus 2b plus c equal to 9. I'll call this equation 2. And also, since we know that minus 2 minus 1 over 9 is the turning point, I have no choice. I think I got to do a differentiation. And by subbing x equal to minus 2, I will know that dy dx will be equal to 0 since that coordinate is the turning point. So let's do a differentiation using quotient rule. In this case, I'll get a dy dx equal to ax squared plus bx plus c. Differentiate x plus 1, I get 1. Minus, now I'll keep x plus 1, I differentiate the denominator. I'll get a 2ax plus b. And I will do a divide by the denominator square. And I know that when x equal to minus 2, dy dx will be equal to 0. And subbing x equal to minus 2, equating dy dx equal to 0 here, I will be able to get this expression here. A minus 2 squared plus b minus 2 plus c minus 2 plus 1. This will be 2a minus 2 plus b equal to 0. I'm ignoring the denominator because when dy dx equal to 0, multiply over to the other side is just equal to 0. And if I were to simplify this expression here, I will be able to get minus b plus c equal to 0. I call this equation 3. And we can use our GC by planting these 3 equations into our GC. I can solve the values of a equal to 2, b equal to minus 1, and c equal to minus 1. For question 2 is a vectors question. We are given 2 vectors a and b, and it's such that the magnitude of the cross product a and b equal to 3. And so it's given that a is a unit vector and b dot b equal to 9. And we are supposed to show that a and b are perpendicular. B dot b equal to 9 and modulus of a cross b equal to 3. Right. And from here, actually, we can, using the a dot b equal to modulus a, modulus b equal to cos theta dot product formula. If we were to replace our a with b, then it will be like b dot with by itself. Then I will end up with a b dot b equal to mod b cosine 0. Since if you dot by itself, the angle between them is equal to 0. Therefore, I can rewrite this into modulus of b squared equal to 9. As for the cross product, we also have a formula for that. And this can be rewritten as modulus of A, modulus of B, sine theta, modulus equal to 3. And in this case, right, since we are given that the A is a unit vector, I will know that this is equal to 1. And from here, I can find that my modulus of B equal to 3. I will just do a subbing values of modulus A equal to 1, modulus of B equal to 3, sine theta equal to 3. And from here, I can solve that theta equal to pi over 2. Therefore, angle between A and B equal to pi over 2. This will just simply implies that A and B are perpendicular to each other. Okay, let's take a look at the next question. For question 3, we are given the equation z cubed equal to az squared plus bz plus c equal to 0, where a, b, c are constant. And you're also given that the roots are 3 and w. For part A, state a condition on a, b, c for the third root to be w conjugate. And we know that for roots to occur in conjugate pairs, it must satisfy certain criteria. The criteria is whereby the coefficient for the equation must all be real. For the third root to be w conjugate, the coefficient of the polynomial or equation must all be real. Therefore, A, B, C must be a subset of a real number. That will be the condition. For part B, given that the condition in part A holds and that w equal to minus 1 plus 2i, find the values of A, B, C. Since the condition for part A holds, we know that the roots will occur in conjugate pairs. Since one of the root is w equal to minus 1 plus 2i, I know that the other root will also be minus 1 minus 2i, and they occur in conjugate pairs. Now, since we have the 3 roots, we can rewrite the 3 roots into a factor form. Therefore, we have z cubed plus az squared plus bc plus c equal to z minus 3, the first root. The second root will be z minus 1 plus 2i. And the last root will be z minus 1 minus 2i. Alright, I think we will do a bit of expansion for the right hand side of the equation. And later on, we will do a comparison with the left hand side. Hopefully, we can solve for the unknown a, b, and c. And for this 2 factor, probably I'm going to do a bit of arrangement to become z plus 1 minus 2i. And we will have z plus 1 plus 2i. The reason why I do that is to express it into like a minus b, a plus b. Then we can expand it relatively fast by doing the a squared minus b squared, which I will get z minus 3. Here will be like z squared plus 2z plus 5. Okay, now we can start to do a comparison of the coefficient. Usually, I will prefer to compare with the constant term first, followed by the highest power. So for the constant term will be the z to the power of 0. For constant term, left hand side is c. The right hand side will just be minus 15. As for the z square, I can see that it will just be a. And here for z square will just be this part here, which is z multiplied by the z here, which is 2. And here will just be minus 3, which give me minus 1. And finally, for z1, left hand side, I will get a b. Right hand side will just be the z component here will just be from here to here, which is 5. And the other one will be from here to here is 6. Therefore, it's equal to minus 1. Therefore, we will have a equal to minus 1, b equal to minus 1, and C equal to minus 15. Okay, let's look at question 4, and it's an inequality question. For part A, we are given this expression 4 over x plus 2, and it's greater or equal to x minus 3 over x, and we are supposed to solve this without using our calculator, and we have a very standard process of solving this kind of inequality. The first thing, I'm going to shift everything to the left hand side and to make the right hand side equal to 0. I'm going to combine these two terms. I will end up with x plus 2 for the denominator. For the numerator, I will get this equation here, and I'm going to expand this and doing a bit of simplification. I should be able to get minus x squared minus 5x minus 6 over xx plus 2 greater or equal to 0. Alright, I'm going to multiply throughout by minus, and I will do a factorize at the same time. I should be able to end up with this factorized form, which is x plus 1, x minus 6 over xx plus 2 lesser or equal to 0. Because I'm multiplying throughout by minus, I need to switch the sign. Alright, I'm going to use the number line to solve this inequality now. We have 4 roots here. The first root we have is minus 2, and the next one will be minus 1, and I will get a 0, and we have a 6 here. Take note, I'm supposed not to include minus 2 and 0 because it will cause the expression to be undefined. And using our calculator and putting in some values for each of the region, I should be able to determine the sign for each region with a plus here, minus, plus, minus, plus. And since we want to solve lesser or equal to 0, I will be taking the region that is negative here, which is this part and this part. Then we can write down our final answer, which is x between minus 2 and minus 1, or x is between 0 or lesser or equal to 6. Okay, let's look at part B now. For part B, the question says, hence solve the inequality of this. And by a bit of pure observation, we can see that actually we are just replacing our x for our part A with a modulus x to get the inequality equation in our part B. I'll just say replace x with mod x. And since our part A answer already found already, the answer for part B basically is just to replace all the x I see with modulus of x. Therefore, I will have this, or modulus x 6. As for this particular part here, it will just be not applicable because modulus of x cannot be negative. That is why there will be no solution for this particular region here. As for this, right, we have two different portions. For this first portion, I want to find a modulus of x greater than 0. For this particular part, if you split up the modulus, you will have like a x greater than 0 or x lesser than 0. In fact, it's actually almost everything except that we have to exclude 0. As for this particular part, likewise, I'm going to split up the modulus. I'll get x between minus 6 and 6. And this is an AND case. And when we do an overlapping between this solution with this solution, the final answer I'll be getting will just simply be x is between minus 6 to 6. But we shouldn't forget to exclude one of the solution here, which is 0. For question number 5 is AP and GP question. We are given that a geometrical series has a first term of A, common ratio R, and the sum to infinity of the series is 18 and the third term is 8 over 3. I'm going to write down this information on the board first. We have U3 equal to 8 over 3, and we know that for GP, the general term formula is AR squared equal to 8 over 3. And I'm going to call this equation number 1. And for sum to infinity is given to be 18. And we know that the formula for sum to infinity of GP is A over 1 minus R, which is 18 here. I'm going to call this equation number 2. And for the first part question, you're supposed to show this particular expression here, 27r cubed minus 27r squared plus 4 equal to a is equal to 0. So I suspect I'm supposed to eliminate away the a from equation number 1 and equation number 2. I'm going to go for equation 1 divided by equation 2. And when we do this divided by this, I will get r squared, 1 minus r. 8 over 3 divided by 18, I will be getting 4 over 27. Alright, I'm going to multiply the 27 to the left hand side. And just expanding and doing a bit of simplification, I should be able to show this cubic equation which the question wants us to show. Alright, that is my part A of the question. As for part B, you are supposed to find the values of R and A. I think I should be able to use our GC to solve this particular cubic equation. By planting this equation into our GC, I should be able to get the values of R, which is R equal to minus 1/3. And we have a 2/3 or 2/3, which is happen to be a repeated root. But for this question, since there's a criteria for R, and it must be lesser than 0, therefore I'm going to reject this too. Therefore, R equal to minus 1/3 since R is lesser than 0. And with this value, I should be able to solve for my A also. I'm going to sub this value back into our equation 1 or 2 is fine. Maybe I'll just sub into our second equation. Substitute R equal to minus 1 over 3 into equation 2. I will get A over 1 minus 1 over 3 equal to 18. And just multiply this over to the right hand side. I can solve that A equal to 24. Right, let's look at part C now. For part C, the question says the nth term of the series is un. I mean, they are just talking about the GP. This GP actually is equal to un. That is the general term. We are given this particular summation and you are supposed to find the value of k. We have 80 summation r equal to k plus 1 to infinity of ur equal to summation r equal to 1 to k of ur. Okay, I think the first thing I'm going to do is to break this expression up. I will have 80. I will change this to become 1 to infinity. Alright, by changing from here to here, we can see actually we are adding in extra terms from 1 all the way to k. Right, from here to here is extra term from 1 to k. Therefore, I need to deduct back from summation of 1 to k of ur. And this right hand side is the same. Okay, I'm going to expand this. At the same time, right, we can actually recognize that this happen to be the sum to infinity because this is sum from 1 to infinity, which happen to be a sum to infinity, which I have the value already, which is equal to 18. Right, I'm going to expand now. So I'll get 80 multiplied by 18 minus 80 summation r equal to 1 of k ur equal to summation r equal to 1 to k of ur. Okay, I'm going to shift this over to the right hand side. I should be getting 81 summation r equal to 1 to k of ur equal 80 multiplied by 18. I should be able to get 1440. Alright, but we do not forget what we are dealing here is all the GP, and this happens to be the sum to k terms of a GP. Right, I'm going to make use of the GP formula here. I'll get 81, which is A bracket 1 minus RK over 1 minus R. Alright, and from our previous part, in fact, we already have the values of A, which is 24 here, and the value of R, which is minus 1/3. Okay, I'm going to sub in this value here. I'll get 81, 24. bracket 1 minus minus 1/3 to the power of k over 1 minus minus 1/3 equal to 1440. Okay, I think we should be able to simplify this without much of an issue. We should be able to end up with 1 minus minus 1/3 to the power of k equal to 1440 over 1458. And finally, we get a minus 1/3 to the power of k equal to 1 over 81. And we can solve this easily, which will give us k equal to 4. That will be my answer for my part C for question number 5. Okay, now let's take a look at question number 6. For question 6, we are given a curve C and an equation of y equal to 2e to the power of x cubed plus a. And t lies on C and has an x coordinate of 1. And we are supposed to use calculus to find the equation of the tangent to C at t. And you're supposed to express your equation into this particular form here, where we are supposed to state the values of p, q, and r. Alright, let's write down the equation first. We have y equal to 2e to the power x cubed plus a. And since the question says we are supposed to find the equation of tangent, okay, I'm going to try to make use of this formula here for equation of tangent. Y minus y1 equal to bracket x m x minus x1. I'm going to differentiate first. Dy dx will just be equal to like differentiate this is the same, then I will have a 3x squared. I will end up with a 6x squared e to the power x cubed, and differentiate a will just be 0. Okay, and we know that when x is equal to 1, okay, I will get a value of y by substituting x equal to 1 here, get 2e plus a. As for my dy dx, also when I submit x equal to 1, I'll get dy dx equal to 6e. Alright, with these values, I can plug inside these values into this equation here. I'll get a y minus 2e plus a equal to gradient will be 6e x minus 1. Okay, and perhaps I can just do a bit of simplification into the form which they want us to express into. I will get y minus 2e minus a equal to 6ex minus 6e. I will end up with y equal to 6ex minus 6e plus 2e plus a. And factorizing out e from here, because this is equal to minus 4e, I take out e, I'll get e 6x minus 4 plus a. And doing a bit of comparison with the form they want, I can write down my values for p, which is happen to be a 6, q will be minus 4, and my r will be equal to 1. Alright, as for part B, it says given that the tangent to C at t passes through the origin. So I know that this expression here will pass us through the origin. I can just substitute x equal to 0 and y equal to 0 into this particular expression here. Therefore, I'll get 0 equal to e minus 4 plus a. I can solve that my a equal to 4e. Okay, that is B part 1. And for B part 2, we are supposed to find the area of the region bounded by the curve C, x equal to 0 tangent at t. Give your answer correct to 1 decimal places. I think I will suggest to do a rough sketch on your GC. At least we have a kind of perspective of how the curve looks like before finding the region. And if you will be using your GC, you can plot out the curve, which will give me something like this. This will be y equal to 2e x to the power 3 plus 4e. Already found the value of a already, which is 4e. And this tangent, right, when x equal to 1, will actually passes through the origin. This is the tangent, y equal to 6 EX. Alright, because this is equal to 4E. So when you multiply E inside, the minus 4E and the plus 4E will cancel away. So I left with a 6EX here. This is origin. Okay, so now we can actually kind of understand where is the region they want us to find. Bounded by C, the x equal to 0 and the tangent. So the required region which I want probably is this particular region here. Okay, let me drop down this line. This is the point where x equal to 1. Okay, with this diagram, I think I should be able to write down what will be the area required. So therefore, the area will just be area underneath this particular curve minus away the area of the triangle. I will do an integration from 0 to 1 of the equation of my curve, which is 2e x to the power of 3 plus 4e dx. This will be this entire region here. Then I will subtract away the area of the triangle here, which is minus half 1, 6e. Alright, and I think the question did not require us to find an exact answer, so I'm probably going to key this entire expression into our GC, and pressing into the calculator, I will get an answer of 5.4 units square. Okay, for question number 7, it seems like it's a method of difference question. Okay, we are given this particular function here, fr equal to cosine r theta. And for part A of the question, we are supposed to show that function of 2r minus 1 minus function of 2r plus 1 is equivalent to this expression 2 sine theta sine 2r theta here. Alright, let's replace our original expression of r with 2r minus 1 first. I will get cosine 2r minus 1 theta. And this, likewise, I'm going to do the same. Cosine 2r plus 1 theta. Okay, I think the best way of simplifying this particular expression is to make use of a factor formula in our MF26. It says that cosine p minus cosine q will give me minus 2 sine half p plus q, and we have a sine half p minus q. Alright, I'm going to make use of this particular formula here, and by subbing this like the p, this is like the q, I will get equal to minus 2 sine half 2r minus 1 theta plus 2r plus 1 theta. Right, this is actually this portion here, and we have a sine half 2r minus 1 theta minus away 2r plus 1 theta. Okay, doing a bit of simplification, I will get equal to minus 2 sine half 4r theta. This is sine half minus 2 theta. And finally, we will arrive with this expression which I'm required to show. Okay, that will be my part A. For part B, also we are given that sine theta is not equal to 0. And we are supposed to show this particular expression here. Alright, for part B. Okay. Let me just write down here. We have a summation of r equal to 1 sine 2r theta. Okay, and I think I'm going to probably make use of the first part A of the question, which we have shown, I think. Okay, we can recognize that this portion here actually is the same as this. I'm going to express sine 2r theta in terms of the rest. Alright, but for this particular summation here, I'm actually only looking at this r as my variable. That means anything other than r is actually a constant. Like for example here, if I were to replace sine 2r theta right with this summation r equal to 1 of 1 over 2 sine theta f2r minus 1 minus f2r plus 1. In fact, this sine theta actually is a constant because anything other than r are all considered as constant. So I'm going to factorize this thing out. I will get 1 over 2 sine theta. And for this particular term left, right, which is this, I'm going to use the method of difference. So firstly, I'm going to sub in when r equal to 1, I'll get actually f1. Minus when r equal to 1, I'll get f3. Okay, I'm going to write 2 more rows at least to see how the pattern is like. I'll get f3 minus f5. I'll get f5 minus f7. Okay, I think that is enough. I'm going to write down the last 2 rows of this. The last 2 rows, it will be an n minus 1 term and an nth term. When I sub in n minus 1, I'll get a f2n minus 3 minus f2n minus 1. And the last row will be f2n minus 1 minus f2n plus 1. Okay, we are going to see there are common terms that will be cancelled away like this. Right, these are the common terms. Therefore, the terms that I will left with is equal to 1 over 2 sine theta. You're just left with f1 and f2n plus 1. Alright, and since we already know what is the definition of fr already, I'm going to replace my r with 1 for this, and I'm going to replace my r with 2n plus 1 for this particular term, which should give me 1 over 2 sine theta. For this case, it will just be cosine theta because when you sub 1 inside here, it's cosine theta. Here, when you sub 2m plus 1 inside here, you're left with cosine 2m plus 1 theta. Okay, I think this is the part which the question wants us to show. That is my part B. Okay, let's look at part C of the question. For part C of the question, say, hence find the 3 possible values of this particular expression here. All right. Okay, let me just write down. For part C, we are supposed to find 3 particular possible values of this pi r over 6 cosine pi r over 6. Okay. I think I'm going to probably do a bit of improvisation to this particular term here because this looks like a sine A, cosine A. Alright, I'm going to rewrite it as a half here and I put it a half 2 here so that I can make use of the double angle formula for sine. And I can rewrite this to become summation r equal to 1 of sine pi r over 3. Alright, in this case actually it's the same as half summation r equal to 1 of sine, okay, 2r pi over 6. Okay, there's a reason why I'm going to do this because right, when I rewrite it into this way, right, I can actually make use of my previous part answer, the part B. You see, there's a sine 2r theta here. I rewrite it into this way so I can recognize that theta basically will just be equal to pi over 6. Alright, that's the reason why I'm doing this step in the first place. Okay, once I have this right, I can make use of my previous part. I'm going to re-express this summation into this standard form that I already showed in my part B. This is what I'm getting over 2 sine pi over 6. Okay. Right, now the question actually wants us to find the 3 possible values. Alright, I'm going to go for maybe 1, 2, 3 first. Let's see how it works out to be. Alright, so when I sub n equal to 1, when n equal to 1, I will get a summation r equal to 1 of this expression, sine pi r over 6, cosine pi r over 6. And I will get a cosine pi over 6 minus cosine pi over 2 over 4 sine pi over 6. I'm just basically subbing 1 into this particular expression here for n. Right? This is what I'm getting. Right? Using our calculator, we can get this to be square root 3 over 2 minus 0 over 4 times half, which give me root 3 over 4. Right? This is the first value that I want. Okay, now let's try when n equal to 2. Alright, I'm going to sub in n equal to 2. I will get right, this is just rewriting the original expression first. Okay, now I'm going to sub in n equal to 2 into this expression here. I'll get like a half. Okay. I will get half cosine pi over 6 minus cosine 5 pi over 6. Let me just carry away the half because I realized that actually I didn't complete this because this part can be cancelled away. Okay, so therefore this one will just be equal to 4 sine pi over 6. This will be root 3 over 2 minus of root 3 over 2. Okay, then this one will be 4 times half. This will give me root 3 over 2. Okay, which is good because it's another different values that I managed to get. Alright, but the thing is, right, I've tried already when you put in n equal to 3, n equal to 4, right, it happens to be repeat of this one and this one. And it's only when you try the next value, which is n equal to 5, then you get a new value. Alright, in this case. So when you try when n equal to 5, okay, I will get a n summation r equal to 1 of sine pi r over 6 cosine pi r over 6. This will give me a cosine pi over 6 minus, alright, sub 5 inside here, you get cosine 11 pi over 6 over 4 sine pi over 6. And this will give me square root 3 over 2 minus of square root 3 over 2 over 4 half. And this is the last value which I will get is actually 0. Okay, now let's take a look at question number 8. Question number 8 is a Maclaurin series question. And firstly, we are given this particular equation here, y equal to cosine 1 minus e to the power of 2x. Okay, I'm going to call this equation number 1 first. And part A of the question, we are supposed to show that this second derivative is equal to the right hand side of this expression. I think probably I'm going to differentiate this 2 more times. Right, when we do first differentiation, I get minus sine bracket 1 minus e to the power 2x. And I'm differentiating inside, I get minus 2e 2x. Okay, let's simplify a bit more. I'll get a 2e 2x sine 1 minus e 2x. Okay, I'm going to call this equation number 2. Right, I'm going to differentiate this another time. I think I'm supposed to make use of product differentiation here because it's comprising of 2 different terms here and here. Okay, and I treat this as one term, this is another term. Okay, I'm going to perhaps keep this, differentiate this first. I'll get a 2e 2x times 2 sine 1 minus e to the power 2x plus, now I'm going to keep this, differentiate this, e2x cosine 1 minus e2x, and I will get minus 2e2x here. Okay, let's simplify a bit. I will get 4e2x sine 1 minus e2x minus 4e4x cosine 1 minus e2x. Okay, and I think I'm going to start to do a bit of replacement from my previous part because the final expression seems like it doesn't contain any like weird terms like trigonometry terms. So I'm going to try to replace away by observing from my previous part, see any replacement here, which I think probably can see somewhere here. This one I can replace with 2 bracket dy dx, right? Because this is 2 times 2. 2e 2x sine 1 minus e to the power 2x is actually dy dx. Alright, similarly for here I can see that for cosine 1 minus e to the power 2x, actually is just y. So therefore, I will get minus 4e 4x and a y. Okay, and I'm going to re-express it into the form which they want. I'll get 2 bracket dy dx minus 2y e to the power 4x. I'm going to call this equation number 3, and this is the expression that I want to show. And by doing a bit of comparison, I think I can say that my k it will be equal to 2. Alright, this is my part A of the question. And for part B, we are supposed to continue to differentiate this and find the first 3 non-zero terms. Alright, in fact, actually, we already first have 3 equations already, but I think if a question phrase it in this way means, right, one of the values, right, will be 0 when I submit x equal to 0 by using the Maclaurin series. So I think probably I am supposed to differentiate this one more time. Okay, I'm going to differentiate this one more time first. You get a d cubed y over dx cubed. Alright, and this, I'm going to use this simple expression here. I will get d square y over dx square for this term here. This, I'm going to make use of my product differentiation. Okay, so here I'm going to keep this first, differentiate this. I get 2 dy dx e to the power of 4x. Now I'm going to keep the y. I'm going to differentiate this. I get a 4e 4x. Okay, I'm not going to waste time to simplify this because I know that to utilize the Maclaurin series, I'm supposed to submit x equal to 0 for these equations here. So I'm not going to waste time to simplify this. Okay, so now I'm going to sub in when x equal to 0. Right, let's look at the first equation. And when x equal to 0, I will get y equal to f0. For this particular term here, I'll get cosine 1 minus e to the power 0, which should give me equal to 1. So therefore, my f0 is 1. Alright, and let's look at my dy dx. dy dx will just be equal to f prime 0. So when x equal to 0 inside here, oh no, I think I end up to be 0, which is expected, right? Else the question will not ask you to differentiate one more time. Okay, so this is a 0 value. Okay, now I'm going to sub in x equal to 0 for my equation 3 here. I get d square y over dx square. When I sum in x equal to 0, I get 2. This is the value of dy dx when x equal to 0, which happen to be against 0. This is minus. This is the value of y when x equal to 0, which is just 1. 1. This is e to the power 0. I will end up with minus 4. Okay, and finally, let's sub in x equal to 0 into our equation 4. I will get a d cubed y over dx cubed equal to 2. Right, this is the d square y over dx square when x equal to 0, which is minus 4. So this is minus 4. This happened to be 0. I don't need to write anything else because everything is 0 here. This one will just be minus 2. Y will just be equal to 1. This is 1. Alright, this is 4e to the power of 0. Alright, simplifying this, keying this in the calculator, I get d cubed y over dx cubed equal to minus 24. So once I have all these values, right, I can just use my MF26 to put in this value into my Maclaurin series expansion. I'm going to write down here. I'll just get y equal to a f0, which is 1, plus x f prime 0, which is 0, plus x squared over 2 factorial of d square y over dx square when x equal to 0 is minus 4 here. And the last one will be plus x cubed over 3 factorial bracket 24 plus dot dot dot. Okay, and I simplify this, I'll get 1 minus 2x squared minus 4x cubed plus dot dot dot. Right, so this will be my answer for my part B. Alright, one more part to go. So we are also given that the first two non-zero terms of a Maclaurin's expansion of cosine 1 minus 2e to the power of 2x, which we have already found already, the first two terms, which is this and this, are equivalent to the first two non-zero terms of the expansion of this one. And this expansion, probably I'm going to make use of my binomial expansion first. Okay, maybe I can just erase this. I will rewrite this equation again. Okay, this one I will get 1 minus 2x squared minus 4x cubed plus dot. Okay. And for this particular expression, 1 over square root a plus bx squared, I'm going to re-express this into a form which I can expand out using my MF26 for the binomial expansion. This will just be equal to a plus bx squared to the power of minus half. Okay, I'm going to factorize out my a. So I will have a to the power of minus half here. 1 plus b over ax squared, power of minus half. I'm going to now apply the formula from my MF. I get a 1 plus minus half. This is b over ax squared. Alright, I think that is sufficient already, because the first two terms which they want us to do comparison actually is just these two terms, which is up to x squared term. So therefore, I don't think it's necessary to continue to expand this. Okay, so once we have this, I just simplify a bit more. I'll get 1 minus b over 2a x squared plus dot dot dot. Okay, I think now it's simple to do a comparison already. From here, I can see for the constant term, I'll get 1 here. So therefore, 1 equal to, the constant term for this one is 1 over root a. From here, I think I can solve my a, which give me equal to 1. Alright, for the coefficient of the x squared term, here is a minus 2. Coefficient of the x squared term here is a minus b over root a times 2a. Alright. Okay, since we already found the value of a already, we can just sub inside here and we can solve that the value of b equal to 4. So therefore a equal to 1, b equal to 4. Okay, so let's move on to question number 9. For question number y, we are given this parametric equation, and the first part wants us to show dy dx equal to kt. X equal to 3t squared plus 2t. And y we have t squared plus 2t cubed. And for part A, I just want to find the derivative of x and derivative of y respect to t first. I'll get 6t plus 2, and this I get dy dt equal to 2t plus 6t squared. And for dy dx, basically it will just be dy over dt divided by dx over dt. 2t plus 6t squared over 6t plus 2. Simplifying this, I think I will just get a t, because when you factorize out a t here, you're left with 6t plus 2, which can be cancelled away. So therefore, dy dx equal to t. Therefore, doing comparison with the form they want you to show, I can just straight away say k equal to 1. For part B, the question says the tangent to C at a point P makes an angle of 60 degrees with the x-axis. Find the x-coordinates of P. Alright, and if the tangent, right, makes the 60 degrees with the x-axis here, actually basically means that this is the tangent theta 60 degrees is actually the same as my gradient dy dx, because for gradient is rise over run, so d rise over run, which is the same as dy dx, which happens to be opposite over adjacent, therefore is tangent theta equal to 60 degrees, which happens to be equal to a dy dx. Therefore, I can just write tangent 60 degrees will be equal to square root 3. And this is my dy dx, which is equal to square root 3. Alright, this will help us to see that actually, in fact, the value of t is just square root 3. And with the value of t, I'm going to sub inside here and here. That will give us the coordinates that we required. Therefore, x will be equal to 3 square root 3 squared plus 2 square root 3, which will give me 9 plus 2 root 3. Same thing for y. I'm going to sub in root 3. I'll get a square plus 2 root 3 cubed. Alright, simplifying this, I'll get a 3 plus 6 root 3. Therefore, coordinates of P is simply x, which is 9 plus 2 root 3, and the y, which is 3 plus 6 root 3. Right, that will be my part B. Also, now we are given Q with coordinates of 16, 20, lie C. Alright, using calculus, find the exact area of the region bounded by the curve, the x-axis, and the line parallel to the y-axis through Q. Alright, I think it's a bit difficult if you just solve this question, try to visualize just by visualizing alone. I think a better way is just do a rough sketch out. Okay, since we have our GC, okay, I'm going to sketch out a graph here using my GC. Alright, this value here will just be like this. Okay, this is a parametric equation. And using the parametric t equal to, which is here, 16, 20. Alright, because this point will lie on this curve here. Alright. By doing observation, right, you can actually immediately see that my value of t actually is just equal to 2. Alright, if you don't want to do observation, actually, you don't need to. You can just equate, then you can solve for the value of t. But I think observation is a valid way of solving the question very quickly. Alright, by a bit of observation, right, I can see that when t equal to 0, alright, x will be equal to 0 and y equal to 0. And when t equal to 2, right, by subbing 2 inside here, I will get x equal to 16 and y equal to 20, which happens to be the point which they have specified for us earlier on. Alright, again, if you don't really like this observation method, you can just equate them together, equate x equal to 16 inside here, then you can solve for the value of t. Okay, so now with this, right, I know that the value when t equal to 2, right, it will lie at this position here. This is 16, 20. Okay, and the question actually wants us to find the exact area bounded by the curve x-axis and the line parallel to the y-axis through Q. So therefore, actually, they want us to find this particular region here. Right, this is 16. Okay, for parametric integration, I'm going to write down the original Cartesian equation for the area first. And I know that the area will just be integration from 0 to 16 of y dx. Alright, and since the question given us is in terms of parametric, I'm going to convert every single thing that I see here into t's, including the limits. Alright, which we already have when x equal to 0, I know that t equal to 0. And when x equal to 16, t equal to 2. And y will just be this, which is t squared plus 2t cubed. And for dx, right, I'm going to replace with my t's from here. You can think of this like a fraction, then you just multiply over to the other side. Okay, but this you try not to write in exam because it's not considered as mathematical logical. Alright, but it's by writing this, but I find that it's very useful. You can just immediately replace the dx with 6t plus 2 dt. Alright, just don't write this in exam. Right, now let's look at the question again, because the question, okay, the question wants us to find the exact area, so we are not allowed to use our calculator. I'm going to just do an expansion for this first. By expanding this, I will get 12t for plus 10t cubed plus 2t squared dt. This will just be a simple integration. Just get a 12t5 over 5 plus 10t4 over 4 plus 2t cubed over 3, 0, 2. And by subbing in the upper limit and the lower limit, I think I will be able to get a final answer of 1832 over 15 units squared. Okay, let us take a look at question number 10 now. For question number 10a, we are supposed to use the substitution of u equal to square root 4x plus 1 and to reduce this particular integral into this expression here, which we are supposed to show. Okay, so maybe we can just square both sides first. We have a u square equal to 4x plus 1 and x equal to u square minus 1 over 4. I'll just write this expression here later for my reference to replace away all the x I see from my original expression. And this is square root 4x plus 1 over x minus 2 dx. I'm supposed to replace all the x away I see for this particular expression here. Okay, and I think I can straight away replace for this part here, which is just u. As for my x minus 2, I already have my x, which is u squared minus 1 over 4. I'll just minus 2 here. And I'm going to replace away the dx also with u. Right, but I'm going to do a differentiation here first. Du dx will just be equal to, this is power half. So I'll get a half 4x plus 1 power minus half. This is a 4. Simplify a bit, I get 2 over square root 4x plus 1. And again, similar to the previous question, I can actually kind of see that dx is the same as square root 4x plus 1 over 2 du. Right, but I'm not supposed to write this in exam again, but it's a useful reference for me because I can just immediately replace my dx with this particular expression here, which is 4x plus 1 over 2 du. And again, for square root of 4x plus 1, I can replace with a u square, which I'm going to do it now. So therefore, this one will just be like sorry, not u square, it's just like a u here. Okay, then I'm going to expand this. This one will just be like a u square. Right, multiply the 2 in. When I multiply the 2 in, I will get like a 2 bracket u square minus 1 over 4 minus 2 du. I think what is left for us to do is just to simplify everything here. I'll just get an integration of u square over 2 bracket u square minus 1 minus 8 over 4 du. And this can be reduced to become a integrate of 2u square over u square minus 9 du. And this is what we need to show. Alright, as for the part B of the question, it says that the region R lies in the first quadrant and is bounded by the curve of this curve and the lines x equal to 6, x equal to 12, y equal to half. And we are supposed to sketch this, giving the coordinates of the intercepts and some of the critical features like equations of asymptote and so on. Okay, I'm going to use my GC to sketch this particular graph. Okay, using GC, and we take note that we just need to sketch this for the region that is x greater or equal to 0. Alright, the asymptotes that I can see, one of the asymptotes is x equal to 2 here. Alright, and the graph, right, if I will use a GC, a sketch, it will look something like this. And this particular point, it will be from here to here. That is when x equal to 0. Alright, the equation sub in x equal to 0 here, I will actually get equal to minus half. So this point will actually be 0 minus half. And since we are supposed to sketch x greater or equal to 0, I think I'm going to bold this to show that I'm including that particular point here. Right, and we also need to indicate x equal to 6, x equal to 12, right? X equal to 6 is actually here. X equal to 6 is somewhere here. This is x equal to 6, x equal to 12. X equal to 12 is here. X equal to 12. And we are supposed to also put in xy equal to 0.5. Y equal to 0.5, I think when you draw the line across, right, using your GC, I think this is slightly lower than when it's x equal to 12. That means this point here is higher than y equal to half. So when I draw y equal to half across here, this should be slightly below this particular point here. This is y equal to half. Alright, with this boundary, this is the region I'm supposed to indicate, right? And this is the region of R. Let me write down the equation of the curve also. Okay, and don't forget one thing here, y equal to 0 also, because this will be the horizontal asymptote. Alright, if you miss out this, probably 1 mark will be deducted also. And now we are supposed to find the exact area of R, giving your answer in the form of A plus B ln C. Alright, I think I'm going to make use of the area of the curve. When you do an integration of the area of curve, in fact, you are actually getting this particular region here. And I'm going to deduct away this area of this rectangle here. Okay, let me just write down. B part 2 and area required will just be equal to region area R. 6 to 12 of y dx and minus away the black region here. This is the area of the rectangle, which will just be base times height. Base will just be 12 minus 6 and the height here will just be half. Okay, with this now I'm going to sub in the equation of my y, which is integrate from 6 to 12 of square root 4x plus 1 over x minus 2 dx minus 3. Alright, and since I already found the integrated version of this particular one, which is this, we have already do the substitution to reduce it into a simpler form already. I'm going to make use of my previous part, okay, but we have to take note of the limits because this limit is x equal to 6, x equal to 12. I'm going to sub x equal to 6 into here. I can see immediately will just be u equal to 5. Alright, when x equal to 6, u will be equal to 5. Likewise, I'm going to do for x equal to 12. So when x equal to 12, you sub inside here, you will get actually square root 49, which is u equal to 7. Therefore, this one will just be from 5 to 7. This is just this particular part here, which is 2u squared over u squared minus 9. And this is du minus 3. Alright, but we are supposed to do it manually because the question asks for exact area. So first and foremost, I think I'm going to do a long division because this is an improper fraction. So I cannot just integrate directly. I'll just do a long division, which will give me integration from 5 to 7 of 2 plus 18 over u squared minus 9 du minus 3. Okay, and if we can recall, in fact, the integration of 1 over u squared minus 9, I can make use of my MF26 again. Right, we are given the formula in the MF26, 1 over x squared minus a squared. When you do an integration of this, you will actually get this one. You will get this ln 1 over 2a ln modulus x minus a, x plus a. Alright, this is given in your MF. I'm going to make use of this formula to integrate this particular expression here. Let me just get rid of this part first. Okay, so I will have, after doing integration, this one I just continue from here. I'll get 2u plus 18, right? 2u is here, plus 18, bracket 1 over 2, 3. Now I'm applying the formula, ln modulus u minus 3 over u plus 3. And this limit is from 5 to 7 minus 3. Okay. Alright, this portion here, I'm using the MF26. Okay, once we have this, now it's time to sub in the limits. So when u equal to 7, when I sub inside, I'll get like a 14 minus 3 ln 4 over 10. Alright, this is the upper limit. Now when I sub in the lower limit, I'll get a 10 plus 3 ln 1/4 minus 3. Alright, and this can be reduced to become 4 plus 3 ln 4 over 10 minus 3 ln 1 over 4. This is minus 3. And therefore, simplifying further, 1 plus 3 ln 16 over 10, 1 plus 3 ln 8 over 5. And this is the form that I'm required to show. And just by doing a bit of comparison, alright, I can straight away state that my A equal to 1, B equal to 3, and my C equal to 8 over 5. Okay, we still have a last part that we need to do. Find the volume generated when R is rotated 2 pi about the x-axis, giving your answer to 2 decimal place. Alright, it's the same region which I'm supposed to rotate about the x-axis. And this time now, I'm probably going to make use of my GC because the question did not ask for exact answer. Alright, so the volume required will just be pi integration from 6 to 12. Alright, same region here, 6 to 12. Now I'm going to write as square root 4x plus 1 over x minus 2 whole thing square, because the formula is pi integrate y squared dx. Then I'm going to minus away the region generated by the black shaded region here. When this one is rotated about x-axis, I will actually get a volume of a cylinder. And volume of a cylinder is given by pi r square h. Minus away pi r, and the r happens to be a radius of half, which is half square. And the h will just be 12 minus 6. 12 minus 6. Right? Therefore, when you key in this entire expression into your GC, the final answer, it will give you 11.04 units square. 2 decimal place because the question requires us to give our answer to 2 decimal place. Right, for question number 11, this is a differential equation question. We have a helicopter hovering at a great height above the ground. And this parachute is dropped from the helicopter. And parachute T falls vertically. And after T seconds, the distance that he has fallen is x meters. At this time, he has a velocity of v, and the motion of the parachutist is modeled by this particular expression here. Alright, we have like d square x over dt square plus alpha dx dt equal to 9.8. And we are also given that for part A, part 1, v is equal to dx dt. And we are supposed to write down a differential equation that involving only v and t. So I think I'm supposed to carry away the x here. I think we are going to start off by doing a differentiation of this one respect to t first. At least we will have like a d square x over dt square term. So I can replace later on. dv over dt will be equal to d square x over dt square. Alright, now with this, right, I think we can start to replace already. Right, this will just be equal to dv over dt plus alpha, and this is just basically is v equal to 9.8. Right, I think this is already the answer for part 1 already. Right, for part 2, given that dv dt equal to 5 and v equal to 2.4, find the value of alpha. I think not a big issue. I just do a substitution into this expression here. I will get like dv dt, which is equal to 5 when v equal to 2.4. Oh, that's about it. So from here, I can solve alpha will be equal to 2. Okay. For part B, it is given that the initial velocity of the parachutist is 0. Alright. Show that v equal to a bracket 1 minus e to the power of bt. Alright. Now I think what we are required to do is just to solve this differential equation. Right. We are supposed to solve this differential equation. Okay, with these values that we already found, right? Okay, let me just rewrite this equation first. dv dt plus 2v equal to 9.8. I'm going to solve this. I think I'm going to go for using the variable separable method. Right, first of all, I'm going to shift this over to the right hand side first. dv dt equal to 9.8 minus 2v. Now I'm going to bring this entire term to the left hand side. I get 1 over 9.8 minus 2v dv dt equal to 1. And integrating both sides respect to t, I will end up with integrate 1 over 9.8 minus 2v dv equal to integrate of dt. Alright, and this, right, I can see this will just be the f prime x over fx kind of integral. After integration, I get minus half ln modulus 9.8 minus 2v, and this is t plus c. Try to make v the subject, multiplying throughout by minus 2 first. I'll get this minus 2t minus 2c. Carry away the ln and the modulus 9.8 minus 2v equal to plus minus e to the power minus 2t minus 2c. And perhaps I will just split this up, e to the power of minus 2t times e to the power of minus 2c. Okay, now just reorder a bit. I will have a final expression of v equal to half 9.8 plus minus e to the power minus 2c times e to the power minus 2t. And I'm going to replace this part here, plus minus e to the power of minus 2c to become a. I'll get a plus a e minus 2t. And I think it's a good idea at the side you should write what is the thing that you are replacing. Let a be equal to plus minus e to the power of 2c. Right, so this will just be my general solution. Right, but we are supposed to solve this particular general solution to get the particular solution. And we know that when t equal to 0, v equal to 0, which is the initial condition given by the question, by subbing t equal to 0, v equal to 0 into this expression, I get 0 equal to half, and this is 9.8. When it's 0 here, you will left with plus a. And from here, I think I can solve a, which will give me minus 9.8. Therefore, my final particular solution will just be v equal to half 9.8 minus 9.8 e to the power minus 2t. Okay, and lastly, I will factorize out 9.8 because I want to make it into this particular form so that I can state the values of a and b. Take out 9.8, I'll get 4.9. 1 minus e to the power minus 2t. Therefore, I can say that my a will just be equal to 4.9 and my b will just be equal to minus 2. Okay. Alright, we still have a last part C. And part C says this helicopter is at a height of 2,000 above the ground. Find the time taken for the parachutist to fall to the ground. Alright. Okay, I'm going to try to do an integration of this particular expression here because we know this is the velocity and we know that when we integrate the velocity, we will actually get the displacement. And this displacement actually is similar to the distance, which is what we need for this particular question because they give us the information the height is 2,000 meters. Okay, so we have here v equal to 4.9, 1 minus e to the power of minus 2t, my previous expression for the velocity. And if I know that if I were to integrate this with respect to time, I'll get my displacement. I will just have an integrate 4.9, 1 minus e to the power of minus 2t dt. Alright, and after doing integration, I'll get 4.9 bracket t plus half e to the power minus 2t plus d. Now I'm going to use d because previously I used c. Right, so not to overlap with the previous answer. And we also know that when t equals 0, the distance actually is equal to 0. T equal to 0, distance will be equal to distance will be x equal to 0. So by putting this value into this expression for my displacement, I can solve d equal to minus 2.45. Therefore, my particular solution for my displacement will just be x equal to 4.9 t plus half e to the power of minus 2t minus 2.45. And given that when x equal to 2000, I'll just sub into this expression here. 2000 equal to 4.9 t plus half e to the power minus 2t minus 2.45. And from here, I can just simply use my GC. I should be able to solve that t equal to 409 seconds. Okay, so now let's take a look at the last question for paper 1, question number 12, which is on a vectors question. Okay, we have here this air traffic controller need to know the exact location of the aircraft. And the coordinates XYZ is in terms of kilometers. Alright, and the base of the control tower is at the location of the origin 000. And the ground is horizontal as modeled by the XY plane. And this aircraft flies along a path with the equation of this given by the equation of the line. And this air traffic controller is situated at a location of like 0.1 above the base of the control tower. Alright, and for part A, it says that due to atmospheric condition, the air traffic controller can only see the aircraft. The furthest distance is like 4 km. Anything that is beyond 4 km, you cannot see the aircraft at all. Alright, part 1 of the question says find the coordinates of this aircraft when it is at the closest point to the air traffic controller. I think this is the part of the question which they test you on the full or perpendicular method, using the full or perpendicular method. For question number 12, okay, let me just write down some of the definition first. Maybe I can just let A be the position of the air traffic controller. Okay, and I know that the air traffic controller is located at 0.1. Right? It's mentioned here that the air traffic controller is 0.1 km above the base of the control tower. Base of the control tower is just like an origin 0. Okay, I'm going to let F be the foot of perpendicular of the aircraft to the air traffic controller. Right, because we know that for foot of perpendicular, right, basically means it's the closest point. Alright, foot of perpendicular means it's the shortest distance from the line to the air traffic controller. Right, that's why I define it to be, let F be the foot of perpendicular first. And since F lies on the line, right, actually I know that my foot of perpendicular will lies on this particular line here. Okay, let me just maybe let L1 be the equation of the line first. This 4, 3, 1. This is the path of the aircraft plus lambda 1 minus 1, 2. And since this one lies on this line, I can just say like for OF will be equal to like 4 plus lambda, 3 minus lambda, 1 plus 2 lambda for some specific value of lambda, right? When we have different values of lambda, it basically means it's different points along that particular line. For some for some lambda or real. Okay, now the situation is basically like this. This is the path, this is the L1. This is the air traffic controller. And we are supposed to find this particular coordinates. This is point A. And from this diagram, I can know that I'm going to make use of my AF dot with the direction of the line equal to 0. So of course, first of all, I'm going to find out what is my AF first. AF will just be OF minus OA. OF is this, which is 4 plus lambda, 3 minus lambda, 1 plus 2 lambda, minus OA, which is 0, 0, 0.1, which will give me final coordinates of 4 plus lambda, 3 minus lambda, 0.9 plus 2 lambda. And I know that if I use AF dot with the direction of this line, based on this diagram, it will give me equal to 0. Alright, this will imply that 4 plus lambda, 3 minus lambda, 0.9 plus 2 lambda, dot with 1 minus 1, 2 will give me equal to 0. Right, we'll just dot this out. I'll get 4 plus lambda minus 3 plus lambda plus 1.8 plus 4 lambda equal to 0. Solving, I will get lambda equal to minus 7 over 15. This is the special lambda I'm trying to find that will give me this position vector here, because different value of lambda, different points along here. I already found this special lambda already. I'm going to sub lambda back into my OF here. This will give me the shortest, the foot of perpendicular that I require to find. So therefore, OF will just be equal to 4 minus 7 over 15, 3 minus 7 over 15, and 1 plus 2 minus 7 over 15. And simplifying this entire expression, I will get 53 over 15, 52 over 15, 1 over 15. Alright, but since the question wants us to find the coordinates, I'm going to express my final answer in the coordinates form. Therefore, coordinates of F will just be equal to 53 over 15, 52 over 15, and 1 over 15. Right, this will be my answer for my part 1. And after that, the part 2 of the question says, hence determine whether the traffic controller will be able to see the aircraft or not. And previously, right, we have mentioned that because due to the poor condition, the air traffic controller can only see the aircraft if it comes within 4 kilometers away. And imagine this is the controller, this is the aircraft, right? Aircraft move along here. So we are going to find actually the distance of this one, right? The distance of this one actually will be the one that is the closest to air traffic controller. If it's already the closest we cannot observe, then the rest of the path of the aircraft definitely the air traffic controller cannot see. Right, I'm going to find what is the modulus of AF. Let me just label this is part A, part 2. Okay, and this, right, I'm going to find out what is my AF first. AF will just be OF minus OA, this minus this. Actually, I can just use this minus this. Right, this minus this, right, I will get like 53 over 15, 52 over 15, 1 over 15. This is the coordinates of F, minus away the coordinate of A. Okay, I'm going to find the modulus of this. Right, simplifying a bit, I will get this position vector here, 53 over 15, 52 over 15 minus 1 over 30, and I'm going to find the distance, which is 53 over 15 square plus 52 over 15 square plus minus 1 over 30 square. And pressing this in the calculator, I'll get a final answer of 4.95. And this is the distance of AF. And since it exceeds the 4 kilometer, therefore the air traffic controller definitely cannot see the aircraft already. So since modulus of AF is greater than 4, traffic controller won't be able to see the aircraft. Okay, this will be my answer for my part 2. Okay, now let's look at part B of this question. I have reproduced the path of the aircraft here. That's the equation given to us in the question. And for part B, we now have a drone that flies along a path with this particular equation here. This is the Cartesian equation. And we are supposed to determine the possible values of k if the path of the aircraft and the drone do not intersect. Alright, when we are given this particular equation here, 2x minus 3 over 3 equal to y plus 1 equal to z minus k over minus 1. This is the form that I don't really want to use to analyze my question, because Cartesian equation in vectors is not really that useful. I'm going to do a conversion for this one into a vector equation or line form similar to this. I will let this entire expression be equal to mu. Alright, I'm going to make x, y, z the subject, which will give me x equal to 3 over 2 plus 3 over 2 mu. Y will just be minus 1 plus mu. And z will just be equal to k minus mu. Okay, I'm going to rewrite this into a vector equation or line form. Let's call this L2 for the path of the drone. And this, right, I can just break this apart. I will get equal to 3 over 2 minus 1k plus mu 3 over 2, 1 and minus 1. This will be the vector equation of my drone. And if the question tells us saying that they shouldn't intersect each other, right? But we can start off by assuming they will intersect first. That means I'll just use this equate with this first. Okay, I will get 4, 3, 1. Let's combine together. Plus lambda minus lambda plus 2 lambda equate to, combine these two together also, 3 over 2 plus 3 over 2 mu minus 1 plus mu k minus mu. Okay, assuming that they intersect first, I'm going to extract out 3 equations here, which I can get from first, second, and third line from the x, y, z component here. I will have like 4 plus lambda equal to 3 over 2 plus 3 over 2 mu, first equation. Second equation, 3 minus lambda equal to minus 1 plus mu, second equation. 1 plus 2 lambda equal to k minus mu equal to third equation. Alright, I'm going to use my equation 1 and 2. I can just quickly solve this equation, very simple, just equation 1 plus equation 2. From here, I can solve lambda equal to 7 over 5 and mu equal to 13 over 5. Alright, and the thing is, right, in order for them to intersect, right, I'm just saying intersect, right, that means to say when you sub in these two unknown, right, into my last equation, which I haven't used yet, right, they will satisfy each other if they intersect. Then the reverse is true. If they does not intersect, that means to say when I sub in this value, 1 plus 2, 7 over 5, shouldn't be equal to k minus 13 over 5. And from here, I can get the value of k equal to, not equal to 32 over 5. Alright, that will be the only answer for k which I cannot include. And since the question says k is a positive constant, therefore, I can say that k can be element of all value except cannot be 32 over 5. Alright. As for part C, you are supposed to find the acute angle between the path of aircraft and drone. That means I want to find the angle between line L1 and L2. Okay, first, maybe I can just say let the required angle be theta. And I know that for angle between two lines, I'm going to use my scalar dot product formula. Cosine theta will just be 1 minus 1, 2 dot with 3 over 2, 1 minus 1 over square root 6. This is square root of 3 over 2 square plus 1 square plus 1 square. And I will put a modular sign, okay, because, oh, I'm sorry, actually I shouldn't put a modular sign. It's okay. Oh, I'm sorry. I'm supposed to put a modular because I missed out this word here. There's a word acute angle. Okay, my apologies. Alright, so from here, I will just dot it out. I will get like a modulus of 3 over 2 minus 1 minus 2 over square root 6. This can be simplified to be square root 17 over 4. And from here, I can work out theta equal to 72.7 degrees. Okay, final part of the question says that it's now given that k equal to 2, and the aircraft and the drone are observed on radar to be closest to each other when they are at the points 431 and 4.2, 0.8, 0.2. What is the distance between the aircraft and the drone at this particular distance? Okay, I think I probably can let OB be my 431 and let my OC be my 4.2, 0.8, 0.2. Okay, let me just make some space here. Okay, let OB be equal to 431 and I will let OC be equal to 4.2, 0.8, 0.2. Alright, since the first part of the question wants us to find the distance between the aircraft and the drone, we're going to find what is BC first. Alright, BC will just be OC minus OB, which is 4.2, 0.8, 0.2 minus away 431, which will give me 0.2 minus 2.2 minus 0.8. I'm going to find the modulus of BC. That is the distance between the aircraft and the drone, which is square root 0.2 square plus minus 2.2 square plus minus 0.8 square. This will work out to become 2.35. I can conclude, therefore, closest distance between them will just be equal to 2.35 kilometer. Since the question already tells us that the closest path right will just be when they are this and this coordinates respectively. And for part 2, we say by considering the vector between the aircraft and the drone, determine whether the distance found in D part 1 is the shortest distance between the both of them. Alright, basically it just means that on a diagram, let's say this is the aircraft. This is the drone. This is the drone. Alright, they are just saying that the closest path right actually is when the two of them is like a right angle. This is the path. Okay, when you are considering this path right, in order for it to be the closest distance right, I know that this will be perpendicular to this and perpendicular to this. And this BC is the one that I already found already, which is BC. Alright, now we are trying to show that whether this is really the closest distance or not. This is what the question wants. Alright, so from this diagram, I can quickly tell whether it will be or not by doing some dotting. That means I can see from this diagram, right, if I use BC dot with this, right, it should theoretically give me 0, right? And this one dot with this, I'm supposed to get 0 also, right? Right? This is the criteria in order for BC to be the shortest distance. Right, therefore, let's try BC dot with 1 minus 1, 2. I will get like 0.2 minus 2.2 minus 0.8 dot with 1 minus 1, 2. Right, dotting this out, right, actually I will get an answer of 0.8, which is not equal to 0. And likewise, I'm going to do for this particular line here, dot with 3 over 2, 1 minus 1, I'll get 0.2 minus 2.2 minus 0.8 dot with 3 over 2, 1 minus 1. When I dot it out, this actually will give me a value of minus 1.1, which is not equal to 0 also. So therefore, I can show that this distance found right will not be the shortest distance already. Okay, let me just do my conclusion here. Therefore, BC is not perpendicular to both the direction of the aircraft and the drone. The distance found previous part is not the shortest distance. Alright, that will be the answer for my D part 2 of the question.